Hi and welcome to Heartbeat Christian Academy. You are in the course called Computer Essentials. And by now you know much more, well I hope you know much more than you used to know or than you knew before you started this course. Just again, there's our contact and our banking details. If you want to support the ministry, you can just use the banking details that's on the screen. And then also there's the contact details if you want to just contact us or you need some notes. So let's go to the manual and just have a look here at the overview. We covered section 1 and we covered section 2. We are now at section 3 and in last lesson 9 we spoke about storage devices. Today we're going to talk about types of memory. Now types of memory can be quite a challenging subject because it can be quite intense in terms of how different memory you get. I mean, you get such a lot of different types of memory. It will really become an extremely complicated conversation if we actually discuss it in detail. But I still want to just give you an overview of the memory, and I want to show you some of the memory so that you can understand when you see memory, you have an idea what you're looking at, especially if we're looking at laptop versus desktop memory, and then old computer versus new computers. There's a lot of technology, a lot of different technologies. We started off with having a single module where it was only ICs on the one side of the chip, and then we had DIP or dual inline modules where you had ICs on both sides of the memory module. So the form factors changed, the size has changed, the voltage changed, and in the next section we'll talk about the sizes and we'll talk about the speed of the memory. But I just want to, in Computer Essentials, I want you to know what you're supposed to know. And today we want to specifically talk about the types of memory, and that is what we're going to try and cover here. I'm just going to switch off the camera for now because I think we're going to have a bit of overlap with a lot of the stuff on the screen. Here we've got random access memory, which is the computer's main memory. And I've showed you this before. I'll just grab a few chips here so that I have them here. And you can just see there on that, you don't need to know this for these Computer Essentials, but it tells you that there's capacitors, there's resistors, there's a module key in the middle where the purpose of this is actually that you can't put DDR2 in a DDR1 or DDR3 board. So for your purposes, it might be easier just to understand DDR1, double data write memory 1, DDR2, DDR3. That's how the RAM improved over the years. And what I mentioned was here's a RAM chip and there is the little slots, and you can see some of them have 2 slots. It's just to avoid that you don't put the wrong RAM in the wrong motherboard. And you can see, like for instance, this chip only has 1 slot in the middle. This chip has 2 slots, and this chip is a totally different size again. This is laptop memory. And you know, like I say, I don't want to get too technical in this course because this course is not supposed to train you to be a computer technician or frighten you away. It's supposed to let you understand the concepts. And the concept of random access memory, as I showed you, is that this is memory that runs, your programs run inside it, running memory. So programs will open up, you open up a lot of programs, it uses this memory primarily to page those files, and this is upgradable. So you can take one chip out and put another chip in, that sort of thing. And the PCB is the printed circuit board. Yeah, I don't think you really, the one thing about the gold fingers and the edge contactors is the fact that in most of the A+ and the technical training they tell you don't touch those, because if you have a static charge on your hands, it could cause damage to the RAM chip. Just some interesting information. So random access memory or main memory is used to store information on a temporary basis, such as test documents or software programs that is currently in use on the PC. So when it's in operation, it runs into the RAM. When you turn the computer off, it's gone. The CPU must transfer the information to the RAM before software can manipulate it. So the central processing unit transfers it to the RAM, and that's basically sort of the main crux of it. Here it's just a very complicated drawing where it just says the CPU registry, and then on your CPU, and I think I mentioned that in one of the previous charts, you have memory, which is your fastest memory. It used to be very little, and it's getting more and more and more. But if the CPU uses its own memory, obviously it speeds up the process. And then we've got the RAM, the random access memory, after that, where it uses it, which is temporary storage. Then we've also got your storage device types, and we spoke about that, which is your ROM, which is your BIOS unit, and we'll talk about that a bit more now. Then we've got the removable drives, the network storage, and the hard drives, and it says there on the side, this is permanent storage, and this is temporary storage. So the physical RAM, the chips, the virtual memory, which the operating system a lot of times can create from hard drive space, actually memory, and then your CPU with the level 1 and level 2 RAM on it. I just thought it would be nice to show you this little pyramid so it just makes sense. Now there it is. You can see there on the screen all the different, not all the different types, but a lot of the different types of RAM. And you can see there's a SIM, single inline module, only ICs on the one side of the chip. There's another SIM, so it's a 30-pin SIM, which was a shorter SIM, then a 72-pin, which was a longer SIM. So this started off with DDR sort of 1 RAM, and then it went to the 184-pin, which started becoming the RAM. And then down here we've got the DDR technology, which is you get 168-pin, 184-pin, and 240-pin, where we started with DDR2. Dual inline modules, DIMMs, means that there's ICs on both sides of the circuit board, and so it's dual inline module. And then here you've got a 240-pin DDR3 DIMM as well. But you can see that the little chip is at a different space, so that will, if you look at it, it will not fit. The module key is different, and they did that on purpose so that you can't put the wrong RAM into the wrong motherboard, because there can be voltage implications and all sorts of things. So and you notice the SODIMMs, the small ones, the DIMMs, SODIMMs, SD RAM, and then also the 200-pin DDR2 SODIMM. This is your laptop memory. So it's in essence a smaller form factor chip, not necessarily smaller in size. I mean, you get, if you get a 4 gig, you get a 4 gig, you get a 8 gig, you get a 8 gig, you get a 16 gig, you get a 16 gig, but it's just the form factor that's smaller so that it can fit into the board. So I wanted to share that with you. And then just here, and I've showed you this physically in the lab here, but you can actually see that's how the RAM is installed. And you can see that little pin, it actually avoids that the RAM can't go in if it's in the wrong position, or even if it's the wrong way around, it can't go in. And normally on your board you have multiple slots. Sometimes you will have 2 blue slots and 2 black slots, and you have to read the motherboard manufacturer's manual, because it will tell you how to run what is known as dual channel memory. I don't want to go into that too much, but it's just advisable from a performance perspective to actually put then the same RAM into the slot. So if you've got 2 blue slots and you've got 2 4 gig chips, to put those 4 gig chips in those slots, and to make sure that they're also running at the same clock speed. Need to know information, just nice to know. It's not necessary for you to really know that. Then we just spoke about RAM, and then I mentioned the word virtual memory, and that's just when the operating system starts using a bit of hard drive space to actually create memory. But the fact is, it is slower memory because it runs on normally a spinning drive or a SSD, depending on. And it just says here that the operating systems are needing ever increasing RAM. I mean, it's really crazy the amount of RAM. Currently I'm recording on a laptop here, gamer's laptop, and I've got 16 gig RAM in it. And we're building computers, and we're starting off at 8 gig. I mean, 4 gig is minimum sort of for Windows 10. The operating systems will normally give you the requirements, but if you're running a Windows 7 machine or something like that, you won't need that kind of RAM. In fact, there's also, I don't know if we're going to share this in the course. I don't think we will. I can't remember if it's in the curriculum, but you will also have limitations as far as 32-bit operating systems and 64-bit operating systems is concerned. And then also there's motherboards that have limitations as far as memory is concerned. Certain chipsets, difficult to explain that, but with Intel, talking about Intel, has different chipset motherboards for the same i3 CPU, but some of them will support more RAM. So you need to look at your motherboard manufacturer. You need to read through your motherboard book when you're buying a motherboard for your computer, or you assembling your own computer, having your own computer assembled. You can make some good decisions as far as how many RAM slots or memory slots you will have on the board, also what the memory speed will be, and also what the maximum supported memory will be on the main board. So those are things that you can think of. But like I say, now at least you know random access memory. If somebody says it's got 4 gig RAM, you know that's the running memory, and you know for Windows 10 that's absolute minimum. And if they say it's got 8 gig memory, or if somebody comes to you and they say they want to upgrade your memory, you understand what it means. If they say they want to upgrade your hard drive, you understand that's your permanent storage memory. One thing more that you need to know, and I've just put in there, and I'm going to talk about this actually in the next lecture, but I've just put in there also the speeds, the speed that the memory communicates on the main board, the running speed in hertz. And remember we spoke about hertz, gigahertz and megahertz. And yeah, when we started off with sort of DDR SDRAM, and then we started with DDR2, we were running from 800 megahertz, and then we started with DDR3, and we were running at 1333, which is sort of just faster memory. And now with DDR4, we're running at 2400 megahertz. Now, I actually saw in our process, I think we've got up to 2800 in the speed of the RAM. So I just wanted to show you that. Then I just need to talk to you, just something else you need to know is that you also get ROM, which is read-only memory, used on the main boards mostly for the basic input-output system, the BIOS. When you start your computer up, your computer does what is known as a post check. So it does a check. It actually runs through a list of checking the hardware even before the operating system engages. The main board has a ROM, a read-only memory chip that hosts the basic input-output system, or what is known as the BIOS system, and that actually does that check. So you need to know that the board has ROM on it, and that ROM is available. It's not upgradable mostly. I've never seen actually ROM being upgradable. So in the olden days, you used to have an IC puller on the older boards and stuff, but these days it's fixed to the board, and you're not going to store files to it. It's going to run a little operating system or a little application called the BIOS system, basic input output system. That system is separate from your operating system in the sense that that system actually checks the hardware, or everything that's connected, the hard drives, the RAM, the network card, all the peripherals, either the fixed peripherals or the removable peripherals in the PCI ports, in the PCI Express ports. The BIOS will check that, and that normally runs on ROM. You used to have like little ROM devices that you can flash the ROMs externally, but these days the updates are normally done through what is known as a BIOS update. It's a BIOS update. It's an application that you run to update your ROM memory. But just to know that there is RAM, random access memory, and they come in different sizes and they come in different shapes, and they're different between laptop and desktop memory, and also even different between server memory. Server memory is totally different. The same in a sense, but different in another sense, because they make it what is known as proprietary. Proprietary hardware means that you can only use the manufacturer's hardware with that particular board. So you will have to, if you have a Dell server or you have a HP server, in most instances, not all instances, but most instances, you will have to buy memory for that specific unit. So that's nice to know. And then also just know about your ROM memory, because you will be asked about that. So we're going to be looking in the next lecture at the RAM measurements. So we're going to be looking at sizes and speeds there. We've spoken a bit about it, but we'll get into that in the next lecture. And I hope I see you in lesson number 11, measuring memory.